What if I told you that everything you've ever touched, every surface you've walked on, every wall that's ever stopped you in your tracks is fundamentally empty space? Not mostly empty, but literally more than 99% pure void, held together by forces so mysterious that the greatest minds in physics still can't fully explain them. This isn't philosophy or poetry. This is the measured, calculated reality emerging from our most sophisticated laboratories. And it's about to change everything you think you know about existence itself. Take a moment to feel the chair beneath you, the ground under your feet. Notice how solid, how real, how absolutely that everything seems. And yet as we speak, particles are tunneling through the atoms in your body, appearing and disappearing from existence trillions of times per second, while the space between your molecules stretches and contracts with the gentle breathing of the universe itself. You are, quite literally, more void than substance, more possibility than certainty, more wave than particle. Welcome to a journey that will take us through the looking glass of modern physics, where the fabric of space-time itself reveals secrets that challenge every assumption we've ever held about the nature of reality. I'm here to guide you through discoveries so profound that they're reshaping our understanding of what it means to exist in this cosmos. And I have to warn you, once you see what we're about to explore together, you may never look at the world quite the same way again. Let's begin where Einstein left off, in the strange realm where space and time dance together as one fabric, where massive objects don't pull on each other through mysterious forces, but instead curve the very geometry of existence itself. Picture, if you will, a vast trampoline stretched tight across the cosmic arena. Now imagine placing a bowling ball in the centre, watching as the fabric dips and warps around its weight. Roll a marble across this curved surface, and it doesn't travel in a straight line. Instead, it follows the contours created by the bowling ball's presence, spiralling inward along paths that we, from our limited perspective, interpret as the force of gravity. This isn't just a helpful metaphor. According to Einstein's general theory of relativity, this is literally how our universe operates. Massive stars, planets, even you sitting in your chair right now, are all creating subtle dimples and curves in the four-dimensional fabric of space-time itself. What we experience as gravity isn't a force pulling us downward, but rather the natural consequence of moving through curved geometry, like water flowing downhill through valleys carved by mass and energy. But here's where things get genuinely unsettling. Recent discoveries in gravitational wave astronomy have revealed something extraordinary about this cosmic fabric. In March 2024, astronomers using an array of pulsars as a galaxy-scale detector announced they had discovered something remarkable, a constant, low-frequency hum of gravitational waves washing over our entire observable universe. Imagine the most subtle vibration, like the barely perceptible tremor you might feel standing next to a massive cathedral organ playing its deepest notes, except this tremor is rippling through the very structure of space and time itself. These waves represent the accumulated echoes of cosmic catastrophes, colliding black holes and merging neutron stars from across billions of years of cosmic history, all superimposed into a background symphony that our universe has been playing since the beginning of time. But the most fascinating aspect isn't just that we can detect these ripples in space-time, it's what they're revealing about the fundamental nature of reality itself. You see, every single one of these gravitational wave detections has aligned with a startling hypothesis emerging from cutting-edge theoretical physics. Some interpretations suggest that our space-time might possess what's called a Binslerian nature, meaning the geometry of space and time isn't quite what Einstein originally described. Instead of the smooth, uniform fabric we once imagined, space-time might be more like a complex tapestry, woven from threads of possibility and probability that behave differently depending on the direction and speed of whatever moves through them. As you listen to this, take a moment to consider the profound implications. The chair you're sitting in, the air you're breathing, the light entering your eyes from the screen, all of these are riding waves in a cosmic ocean that's far stranger and more dynamic than we ever suspected. Every heartbeat sends tiny ripples through local space-time. Every step you take creates microscopic distortions in the fabric of reality. You're not just in the universe, you are the universe, temporarily organized into the pattern that experiences itself as you. But if space-time itself is more fluid and mysterious than we thought, what does that tell us about the nature of the matter and energy that supposedly curves it? This question leads us into even stranger territory, into the realm where the solid boundaries between things begin to dissolve entirely. Let's journey now into the quantum realm, that bizarre landscape that exists beneath the threshold of everyday experience. Here, in the space smaller than atoms, smaller than the components of atoms themselves, we encounter phenomena so counterintuitive that even the physicists who study them admit they don't fully understand what's happening. At these incredibly tiny scales, the very concept of a particle, of a discrete thing with definite properties existing in a specific place at a specific time, simply breaks down. Instead, we find probability clouds, wave functions that represent not where something is, but where it might be found if someone looks. An electron doesn't orbit the nucleus of an atom like a tiny planet around a star. Rather, it exists as a shimmering field of potential, simultaneously everywhere and nowhere, until the moment of measurement collapses this field of possibility into a single, definite outcome. The mathematics describing these quantum phenomena work with extraordinary precision. We can predict the statistical outcomes of quantum experiments to more decimal places than we can measure the circumference of the Earth in terms of atomic widths. Yet the underlying reality these equations describe remains profoundly mysterious. What exactly is a probability wave? How does a particle decide which of its possible states to manifest when observed? And perhaps most unsettling of all, why does the act of observation seem to play such a fundamental role in determining what becomes real? This isn't just academic speculation. The quantum realm directly impacts your daily life in ways you might never have imagined. The device you're using to watch this video operates through quantum mechanical principles. The light illuminating your surroundings behaves according to wave-particle duality. Even the chemical reactions occurring in your brain as you process these ideas follow quantum rules that blur the boundaries between cause and effect, between observer and observed. Recent experiments have pushed these quantum mysteries into ever more mind-bending territory. Scientists have successfully demonstrated quantum entanglement between particles separated by hundreds of miles, a phenomenon Einstein famously called spooky action at a distance. When two particles become entangled, measuring the properties of one instantly determines the properties of the other, regardless of the distance separating them. This happens faster than light could travel between the particles, suggesting that our intuitive understanding of space and time as fundamental barriers to communication might be incomplete. Even more remarkably, researchers have begun exploring what happens when quantum effects scale up to larger and larger systems. They've created quantum superpositions in molecules containing hundreds of atoms, demonstrated quantum entanglement in systems visible to the naked eye, and even proposed experiments that might detect quantum effects in living organisms. The boundary between the quantum realm and the classical world of everyday experience appears to be far more porous than anyone previously imagined. Some interpretations of quantum mechanics go even further, suggesting that consciousness itself might play a fundamental role in the structure of reality. The measurement problem in quantum physics, the question of how and why wave functions collapse into definite outcomes, remains one of the deepest, unsolved mysteries in science. Various interpretations propose radically different solutions, from multiple parallel universes where every possible outcome occurs simultaneously, to participatory models where conscious observation actively participates in creating reality. Now you might be wondering, what does all this have to do with the fabric of space-time we discussed earlier? The answer reveals itself when we consider that space, time, matter, energy, and information might not be separate categories at all, but different aspects of a single, unified phenomenon that we're only beginning to understand. Take a deep breath and let this sink in for a moment. The solid matter you're made of follows quantum rules that challenge the very notion of solidity. The space-time you exist within ripples and waves in response to gravitational disturbances across cosmic distances. And the line between observer and observed, between consciousness and physical reality, remains mysteriously blurred despite centuries of scientific investigation. You're living at the intersection of all these mysteries, a conscious pattern temporarily organizing matter, energy, space, and time into the experience of being you. This brings us to one of the most revolutionary ideas emerging from modern physics: the possibility that space-time itself might not be fundamental at all, but rather an emergent property arising from more basic quantum informational processes. Imagine discovering that what you thought was solid ground beneath your feet was actually the surface tension of an infinitely deep ocean, with currents and depths extending far beyond anything you could previously perceive. The holographic principle, emerging from string theory and black hole physics, proposes exactly this kind of radical revision to our understanding of reality. According to this principle, all the information contained in any volume of space can be encoded on the boundary of that volume, much like a hologram stores a three-dimensional image in a two-dimensional surface. If this principle applies to our universe as a whole, then our experience of three-dimensional space, of depth and volume and substance, might be a kind of holographic projection arising from information encoded on a distant two-dimensional boundary. Recent computational studies have provided mathematical validation for these holographic theories. Researchers have successfully demonstrated that the thermodynamics of certain black holes can be perfectly reproduced using calculations performed in a lower dimensional space. This suggests that the third dimension of space, the very dimension that gives objects their apparent solidity and substance, might be as much of an illusion as the depth you perceive when looking at a hologram. The implications stretch far beyond physics into philosophy and neuroscience. If our three-dimensional reality is indeed a holographic projection, then what we experience as physical matter, including our own bodies and brains, might be emergent patterns in a fundamentally informational universe. This doesn't make our experiences less real or meaningful, but it does suggest that reality operates on levels far deeper and stranger than we typically imagine. Consider for a moment what this might mean for your own existence. The thoughts you're thinking right now, the emotions you're feeling, the sense of being located in a particular place at a particular time. All of these might arise from informational processes occurring in dimensions beyond our direct perception. You're not just in the hologram, you are the hologram, a conscious pattern emerging from the vast computational processes underlying apparent reality. This holographic perspective aligns remarkably with discoveries in neuroscience about how our brains construct our perception of reality. Your brain doesn't simply record sensory information like a camera or microphone. Instead, it actively constructs your experience of the world, filling in gaps, making predictions, and creating a seamless narrative of consciousness from the fragmentary and incomplete data provided by your senses. Optical illusions demonstrate just how constructed this experience really is. Your brain can be easily fooled into seeing motion where there is none, depth where surfaces are flat, colours that aren't actually present in the light entering your eyes. What's particularly fascinating is that these aren't errors or glitches in perception. They're features, evolutionary adaptations that allow your brain to make sense of an incredibly complex and ambiguous sensory environment. If our brains are constantly constructing our experience of reality from incomplete information, and if the physical universe itself might be a holographic projection from more fundamental informational processes, then the question of what constitutes real reality becomes genuinely perplexing. Where does the constructed nature of perception end and objective physical reality begin? Some interpretations suggest this distinction might not exist at all, that consciousness and physical reality might be different aspects of the same underlying informational substrate. As we venture deeper into these mysteries, we encounter the profound question of dark matter and dark energy, the invisible components that appear to make up more than 95% of our universe. Everything we can see, touch, and directly measure, every star and galaxy and planet, every atom in your body, represents less than 5% of the total cosmic inventory. The rest consists of dark matter, which interacts with ordinary matter only through gravity, and dark energy, which appears to be accelerating the expansion of space itself. Think about this for a moment. The overwhelming majority of the universe consists of components that are completely invisible to us, that don't emit, absorb, or reflect light, that we can only detect through their gravitational effects on the small fraction of reality that we can directly observe. It's as if we're trying to understand a vast symphony by listening only to a single, barely audible instrument, while the rest of the orchestra plays in frequencies we cannot hear. Recent discoveries have made this situation even more puzzling. Observations of distant supernovae revealed that the expansion of the universe isn't slowing down due to gravity, as everyone expected, but actually accelerating. Something is pushing space apart faster and faster, overcoming the gravitational attraction of all the matter and energy we can see. This dark energy appears to be a property of space itself, becoming stronger as space expands, as if the vacuum of empty space contains a hidden reservoir of energy that grows as the universe grows. What kind of reality are we living in, where the vast majority of existence is invisible to us, where empty space itself possesses mysterious properties that determine the fate of the cosmos? These discoveries suggest that our entire framework for understanding reality might be fundamentally incomplete, that we're missing crucial pieces of the cosmic puzzle that would dramatically change our perspective on everything we think we know. Some researchers have proposed that dark matter might exist in a kind of parallel sector of reality, a hidden valley of particles and forces that share space with our ordinary matter but interact with it only gravitationally. Others suggest that dark energy might arise from the quantum mechanical properties of vacuum space itself, from the constant appearance and disappearance of virtual particle pairs that quantum mechanics requires even in apparently empty space. These possibilities point toward a cosmos far stranger and more layered than anything our ancestors could have imagined. You're not just living in a universe, you're living in what might be a multiverse, a vast assemblage of parallel realities, hidden dimensions, and emergent properties that we're only beginning to glimpse through the narrow window of human perception and measurement. As you absorb these ideas, notice how they might shift your perspective on your own place in this cosmic mystery. You're not a separate observer looking at an external universe. You're an integral part of the universe, observing itself, a temporary organization of matter, energy, space, and time that has somehow become conscious of its own existence. The atoms in your body were forged in the cores of ancient stars. The thoughts in your mind follow quantum mechanical principles, and the space you occupy participates in the cosmic expansion that's carrying galaxies apart across billions of light years. This is where our journey takes its next surprising turn, as we explore what happens when we consider the possibility that information, rather than matter or energy, might be the most fundamental constituent of reality. In the late 1990s, physicists working with some of the most powerful telescopes ever built made a discovery that fundamentally shattered our understanding of cosmic reality. They were measuring the brightness of distant supernova, cosmic lighthouses billions of light years away, expecting to find evidence that the universe's expansion was gradually slowing down. Instead, they discovered something that defied every prediction, every model, every assumption about how reality should behave. The universe wasn't slowing down at all. It was speeding up, accelerating into the cosmic darkness at an ever-increasing rate, driven by something so mysterious that we can only call it dark energy. This discovery didn't just add a new chapter to physics textbooks. It revealed that our entire conception of reality was built on incomplete foundations. The force driving this acceleration appears to be a property of space itself, growing stronger as space expands, as if the vacuum between galaxies contains an inexhaustible reservoir of energy that becomes more powerful the more it stretches. Imagine discovering that the air around you becomes more dense the more it spreads out, that emptiness itself possesses weight and influence beyond anything you could measure or touch. As you contemplate this idea, notice how it might shift your sense of the space around you right now. The room you're in, the gaps between objects, even the space between your thoughts, all of it participates in this cosmic expansion. You're not sitting in empty air, you're immersed in a dynamic field of dark energy that's literally growing stronger with every passing moment, pushing the fabric of space-time apart at scales so vast that your entire galaxy is just a tiny island of matter floating in this expanding sea of invisible force. This brings us to a profound realization that's emerging from the convergence of quantum mechanics, information theory, and cosmology. What if the solid, substantial reality we experience is fundamentally informational in nature? What if matter, energy, space, and time are all different expressions of underlying computational processes that we're only beginning to understand? Consider the device you're using to experience this content right now. At its most basic level, it's processing information, manipulating patterns of ones and zeros to create the images, sounds, and sensations you're experiencing. but zoom into the quantum level of its components, into the behavior of the electrons flowing through its circuits, and you'll find that these particles don't exist as discrete objects with definite properties. Instead, they exist as probability distributions, mathematical patterns that describe not what is, but what might be observed under different circumstances. The boundary between information and physical reality becomes even more blurred when we examine what physicists call the holographic principle. Recent computational studies have demonstrated something remarkable: that all the information contained within any volume of space can be perfectly encoded on the boundary of that volume. Much like a hologram stores a three-dimensional image on a two-dimensional surface. If this principle applies to our universe as a whole, then our experience of depth, volume, and three-dimensional substance might be analogous to the apparent depth you perceive when looking at a hologram. Leonard Susskind, one of the theoretical physicists who helped develop these ideas, describes it as discovering that the thermodynamics of certain black holes can be reproduced from a lower dimensional universe. This means that what appears to be happening in 3 dimensions of space might actually be the projection of information processing occurring in just 2 dimensions. The 3rd dimension, the very dimension that gives objects their apparent solidity and substance, might be as much of an emergent illusion as the depth you see in a holographic display. Take a moment to consider what this might mean for your own existence. The thoughts you're thinking, the emotions you're feeling, the sense of having a body located in a particular place at a particular time, all of these experiences might arise from informational processes occurring in dimensions beyond your direct perception. This doesn't make your experiences less real or meaningful, but it does suggest that reality operates through layers of organization far more subtle and complex than everyday experience reveals. This informational view of reality aligns remarkably with discoveries in neuroscience about how consciousness constructs experience. Your brain doesn't simply record sensory information like a passive recording device. Instead, it actively constructs your perception of reality, constantly making predictions, filling in gaps, and creating a coherent narrative of experience from fragmentary and often contradictory sensory data. Optical illusions provide a fascinating window into this constructive process. When you see apparent motion in a static image, or depth where there is only a flat surface, or colours that aren't actually present in the light reaching your eyes, you're witnessing your brain's sophisticated reality construction algorithms in action. These aren't glitches or errors in perception. They're features, evolutionary adaptations that allow your neural networks to create useful models of reality from incomplete and ambiguous information. Some interpretations suggest that this constructive process might extend far beyond individual consciousness into the fundamental structure of physical reality itself. The measurement problem in quantum mechanics, the question of how and why quantum possibilities collapse into definite outcomes, remains one of the deepest unsolved mysteries in science. Various interpretations propose radically different solutions, from multiple parallel universes where every possible outcome occurs simultaneously, to participatory models where observation plays an active role in determining what becomes real. The participatory universe hypothesis, proposed by physicist John Wheeler, suggests that reality might not exist in any definite form until it's observed. This remains a speculative interpretation, not a proven scientific fact, but it points toward a cosmos that's far more interactive and consciousness-dependent than classical physics ever imagined. If this interpretation has any validity, then you're not just passively observing reality from the outside, you're actively participating in its ongoing creation through the very act of conscious observation. Consider the profound implications of this possibility as you listen. Every time you focus your attention, every moment of conscious awareness, every decision to observe one aspect of reality rather than another might be participating in the cosmic process through which potential becomes actual, possibility becomes experience. This doesn't mean you can control reality through wishful thinking. This is not a scientifically supported claim, but it does suggest that consciousness and physical reality might be more intimately connected than we typically assume. This brings us to one of the most mysterious aspects of quantum mechanics, the phenomenon of quantum entanglement. When two particles become entangled, measuring the properties of one instantly determines the properties of the other, regardless of the distance separating them. This happens faster than light could travel between the particles, suggesting that our intuitive understanding of space and time as fundamental barriers to communication might be incomplete. Einstein famously called this spooky action at a distance, and it troubled him deeply because it seemed to violate the principle that nothing can travel faster than light. Recent experiments have confirmed that quantum entanglement is indeed real, and that the correlations between entangled particles cannot be explained by any local hidden variable theories. The particles don't communicate in any conventional sense, yet their properties remain mysteriously coordinated across vast distances. What makes this particularly fascinating is that quantum entanglement reveals something profound about the nature of information in the universe. When particles become entangled, they don't just share correlations, they share a single quantum state that encompasses both particles simultaneously. In a very real sense, entangled particles cease to be separate entities and become parts of a larger, non-local quantum system that transcends ordinary spatial boundaries. Some researchers have proposed that quantum entanglement might provide insights into the nature of consciousness itself. This remains highly speculative and not scientifically proven, but the correlations observed in quantum systems do share certain formal similarities with the binding problem in neuroscience, the question of how separate neural processes combine into unified conscious experience. Both phenomena involve the mysterious integration of distributed information into coherent, unified states. As you reflect on these ideas, you might notice how they challenge the boundaries between self and other, between inner and outer, between observer and observed. If quantum entanglement reveals that apparently separate particles can share unified states that transcend spatial separation, and if consciousness involves similar processes of integration and unification, then the sharp boundaries we typically draw between different aspects of reality might be more fluid than we imagine. This fluidity becomes even more apparent when we consider the role of information in modern physics. Every interaction between particles can be understood as an exchange of information. Every measurement reveals information about quantum states. Every computation processes information according to physical laws. The convergence of physics and information theory suggests that information might be more fundamental than matter or energy, that physical reality might be computational in nature at its deepest levels. Peter Woit of the Simons Foundation describes this convergence. What we have learned from holography and other developing theories is that the language of information theory is useful for understanding quantum gravity. When information theory and quantum people talk to each other, we understand more deeply how the hologram encodes the three-dimensional information. This suggests that the apparent three-dimensionality of space might be an emergent property of underlying information processing, much like the apparent motion in a movie emerges from the rapid succession of still frames. The implications extend far beyond theoretical physics into our understanding of what it means to exist as conscious beings in an informational universe. If physical reality is fundamentally computational, then consciousness might represent a particular type of information processing that's capable of observing and understanding its own computational substrate. You're not just in the universe, you might be the universe computing itself into conscious awareness through the intricate patterns of neural activity in your brain. This perspective aligns with emerging theories in cognitive science that describe consciousness as an integrated information system. According to integrated information theory, consciousness corresponds to integrated information, the amount of information generated by a system above and beyond its parts. This remains a developing scientific framework, but it suggests that consciousness might be a fundamental feature of information processing systems, rather than something that mysteriously emerges from purely material processes. As we delve deeper into these mysteries, we encounter the profound puzzle of dark matter and dark energy, the invisible components that dominate our universe. Current observations suggest that ordinary matter, everything we can see and touch and directly measure, comprises less than 5% of the total cosmic inventory. The remaining 95% consists of dark matter, which interacts gravitationally but doesn't emit light, and dark energy, which drives the accelerating expansion of space itself. Think about the implications of this cosmic composition. The overwhelming majority of reality consists of components that are completely invisible to us, that we can only detect through their gravitational effects on the tiny fraction of the universe that we can directly observe. It's as if we're trying to understand a vast symphony by listening to a single, barely audible instrument, while the rest of the orchestra plays in frequencies beyond our perception. Some interpretations suggest that dark matter might exist in what physicists call a hidden valley, a parallel sector of reality that shares space with ordinary matter but interacts with it only gravitationally. This hidden sector might contain its own particles, forces, and even complex structures that remain completely invisible to our instruments. You might be surrounded right now by an entire hidden universe of dark matter flowing through your body and the space around you without leaving any trace of its passage. Dark energy presents an even deeper mystery. Unlike dark matter, which clumps together gravitationally and helps structure the cosmic web, dark energy appears to be a property of space itself. As space expands, dark energy becomes stronger, pushing galaxies apart at an ever-accelerating rate. Some theoretical models suggest that this energy might arise from quantum fluctuations in the vacuum of space, from the constant appearance and disappearance of virtual particle pairs that quantum mechanics predicts even in apparently empty regions. If dark energy does arise from quantum vacuum fluctuations, then the empty space around you is far from empty. It's a seething ocean of quantum activity, with particle-antiparticle pairs constantly materializing and annihilating in timescales so brief that they exist below the threshold of direct observation. This quantum foam might be the source of the mysterious force that's determining the ultimate fate of our universe, expanding space at an exponential rate that will eventually separate all galaxies beyond the possibility of communication. As you contemplate these ideas, notice how they might shift your sense of the space around you. The gaps between objects, the air you're breathing, even the vacuum of space itself, all of it might be alive with invisible activity and hidden energies that shape the evolution of the cosmos on the grandest possible scales. You're not sitting in empty space. You're immersed in a dynamic field of quantum possibilities and dark energies that connect you to the deepest mysteries of cosmic evolution. This brings us to one of the most profound questions emerging from modern physics. If the universe is fundamentally informational, if consciousness participates in the collapse of quantum possibilities, if dark matter and dark energy dominate reality while remaining invisible to direct observation, then what does it mean to say that anything is real in an objective, mind-independent sense? Some interpretations of quantum mechanics suggest that reality might be fundamentally participatory, requiring conscious observers to actualize possibilities into definite outcomes. This remains highly speculative and controversial, not a proven scientific fact, but it points toward a cosmos that's far more interactive and observer-dependent than classical physics ever imagined. The boundary between subjective experience and objective reality might be more porous than we typically assume. Consider the possibility that what we call objective reality might be more like a collaborative construction, emerging from the interactions between conscious observers and quantum possibilities. This doesn't mean you can control reality through wishful thinking, or that individual consciousness creates the physical world. These are not scientifically supported claims, but it does suggest that the sharp distinction between mind and matter, between observer and observed, might be less fundamental than it appears. This perspective finds unexpected resonance with the ancient philosophical traditions that described reality as fundamentally experiential or consciousness-based. While these traditions developed their insights through contemplative rather than experimental methods, the convergence is striking. Modern physics and ancient wisdom seem to be pointing towards similar conclusions about the participatory, observer-dependent nature of reality, though they arrive at these insights through completely different pathways. The implications for your own existence are profound. If reality is indeed participatory and informational, then you're not a passive observer looking at an external universe. You're an active participant in the ongoing creation of reality through your conscious awareness. Your choices of attention, your decisions about what to observe and how to interpret your observations. This doesn't grant you magical powers over the physical world, but it does suggest that consciousness plays a more fundamental role in the structure of reality than materialistic perspectives typically acknowledge. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready, though there's no pressure to decide right now. As we continue our journey through these mysteries, we encounter the fascinating possibility that our universe might not be unique. The concept of a multiverse, multiple parallel universes existing simultaneously, emerges naturally from several different areas of physics. Cosmic inflation theory suggests that our observable universe might be just one bubble in an endless foam of expanding space-time regions, each with potentially different physical laws and constants. Quantum mechanics offers another pathway to multiple realities through the many worlds interpretation. According to this view, every quantum measurement doesn't collapse possibilities into a single outcome, but rather branches reality into multiple parallel worlds where each possible outcome occurs. The measurement doesn't eliminate possibilities, it separates them into different branches of an ever-expanding tree of parallel realities. These interpretations remain highly speculative and not scientifically proven, but they suggest that the reality you're experiencing right now might be just one thread in an infinite tapestry of parallel possibilities. In other branches of the quantum multiverse, slightly different versions of you might be listening to slightly different versions of this content, having made different choices that led to different outcomes. Every decision point, every quantum measurement, every moment of conscious choice might be spawning new branches of reality. The mathematical multiverse, proposed by cosmologist Max Tegmark, goes even further, suggesting that all mathematically consistent structures exist as physical realities. In this view, every possible universe that can be described mathematically actually exists somewhere in the larger structure of reality. Our universe, with its particular physical constants and laws, would be just one member of an infinite ensemble of mathematical possibilities made manifest. These multiverse theories challenge our intuitive sense of uniqueness and specialness. If infinite parallel realities exist, containing infinite variations of every possible story, then what makes your particular experience significant? Paradoxically, the answer might be that significance doesn't depend on uniqueness. Your consciousness, your capacity for awareness and understanding, remains meaningful regardless of how many parallel versions might exist in other branches of reality. As you reflect on these possibilities, you might notice how they expand your sense of potential and possibility. If multiple realities exist, if consciousness participates in selecting which branch of possibility becomes your experience, then every moment presents genuine choices with real consequences for the trajectory of your particular thread through the cosmic tapestry. This doesn't mean you can control which universe you inhabit, but it does suggest that your conscious choices matter in determining which aspects of infinite possibility become your lived reality. This brings us to the emerging field of quantum biology, where researchers are discovering quantum effects in living systems. Photosynthesis, the process that converts sunlight into chemical energy in plants, appears to use quantum coherence to explore multiple pathways simultaneously and select the most efficient route for energy transfer. Navigation in birds might involve quantum entanglement in specialized proteins that interact with Earth's magnetic field. Even the sense of smell might operate through quantum tunneling effects that allow molecules to be identified by their vibrational frequencies. These discoveries suggest that life itself might be a quantum phenomenon, that consciousness and biological processes might operate according to quantum mechanical principles that blur the boundaries between classical and quantum reality. This remains an active area of research with many open questions, but it points toward a deeper integration between consciousness, life, and the fundamental structure of reality than we previously imagined. The implications for human consciousness are particularly intriguing. If biological processes can maintain quantum coherence, if living systems can exploit quantum effects for information processing, then the boundary between classical neural computation and quantum information processing in the brain might be more fluid than neuroscience typically assumes. This doesn't mean consciousness is purely quantum mechanical. This remains unproven, but it does suggest that the relationship between mind and matter might involve quantum processes that we're only beginning to understand. Some researchers have proposed that consciousness might involve quantum processes that allow the brain to access non-local information, to integrate distributed neural processes into unified experiences, or even to interact with quantum fields that extend beyond the physical boundaries of the brain. These ideas remain highly speculative and controversial, not proven scientific facts, but they point toward possibilities for understanding consciousness that transcend purely materialistic explanations. As we approach the end of our exploration, we encounter the profound question of what all these discoveries might mean for your daily experience of being conscious in this mysterious universe. The solid matter you're made of follows quantum rules that challenge the very notion of solidity. The space-time you exist within ripples with gravitational waves from cosmic catastrophes billions of years old. The reality you perceive might be a holographic projection from information processing in lower dimensions. And consciousness itself might participate in the fundamental processes through which possibility becomes actuality. These aren't just abstract theoretical ideas. They're invitations to experience reality with greater wonder, curiosity, and humility. Every breath you take involves quantum processes in your cells. Every thought you think participates in the universe's ongoing exploration of its own possibilities. Every moment of conscious awareness represents the cosmos temporarily organizing itself into patterns capable of understanding and appreciating their own existence. The boundaries between self and universe, between consciousness and physical reality, between known and unknown, all prove to be far more fluid and mysterious than everyday experience suggests. You're not separate from the cosmic dance of quantum possibilities, gravitational waves, and dark energies. You are the cosmic dance, temporarily organized into the pattern that experiences itself as your particular perspective on reality. As you integrate these ideas, remember that mystery isn't a problem to be solved, but a reality to be lived. The deepest truths about consciousness and cosmos might not be reducible to simple explanations or final answers. Instead, they might be invitations to participate more fully in the ongoing creativity of a universe that's constantly exploring new possibilities through the conscious beings it brings into existence. The journey through these mysteries reveals that reality is far stranger, more wonderful, and more participatory than our ancestors ever imagined. You're living at a unique moment in cosmic history, when conscious beings have developed the tools to glimpse the deepest structures of existence, to detect gravitational waves from the beginning of time, and to probe the quantum foundations that underlie all apparent solidity. And perhaps most remarkably of all, these investigations are revealing that consciousness itself might not be an accidental byproduct of cosmic evolution, but rather an integral feature of how the universe explores and realizes its own infinite potential. In becoming conscious, the cosmos achieves the capacity to know itself, to wonder about its own nature, and to participate in its own ongoing creation through the choices and awareness of conscious beings like you. For a deeper exploration of how these temporal mysteries might affect your personal experience of time and memory, I invite you to watch What If the Past Never Ended and You're Still in It?, where we'll discover how the nature of time itself might be far stranger than you've ever imagined. This profound interconnectedness reveals itself most dramatically when we examine what physicists call the information paradox of black holes. These cosmic monsters, regions where space-time curves so severely that not even light can escape, present us with one of the most troubling puzzles in modern physics. According to our understanding of thermodynamics, information cannot simply vanish from the universe, yet black holes seem to do exactly that, swallowing matter, energy, and all the information they contain, apparently erasing it from existence forever. Stephen Hawking's discovery that black holes emit radiation and eventually evaporate made this paradox even more perplexing. If a black hole slowly radiates away all its mass and disappears completely, what happens to the information that fell into it? Does it simply cease to exist, violating one of the fundamental principles of physics? Or does it somehow escape in the radiation, encoded in ways so subtle that we haven't yet learned to detect it? Recent developments in holographic theory suggest a startling resolution to this puzzle. The information that falls into a black hole might never actually cross the event horizon from the perspective of an outside observer. Instead, it might remain encoded on the surface of the black hole, scrambled and stretched but never truly lost. From your perspective, watching matter fall toward a black hole, you would see it slow down and freeze at the horizon, its information spread across the surface like a hologram, while the infalling matter itself experiences crossing the horizon and continuing inward. This suggests that information, rather than matter or energy, might be the most fundamental conserved quantity in the universe. Every interaction, every quantum measurement, every collapse of a wave function involves the processing and transformation of information according to physical laws that we're still learning to understand. You're not just a collection of atoms arranged in a particular pattern. You're a complex information processing system, constantly exchanging data with your environment, maintaining your identity through the continuous flow of information rather than through any static material structure. As you contemplate this idea, notice how it might shift your understanding of personal identity and continuity. The atoms in your body are constantly being replaced through metabolism, breathing, and cellular renewal. The thoughts in your mind are constantly changing, flowing from moment to moment like a river that never contains the same water twice. What remains constant isn't any particular material or mental content, but rather the informational patterns that organize these constantly changing components into the coherent experience you recognize as yourself. This informational view of identity aligns remarkably with discoveries in neuroscience about how the brain maintains consciousness across time. Your sense of being a continuous self doesn't arise from any single brain structure or neural process, but rather from the integration of distributed information processing systems that create coherent narratives from moment to moment. Memory doesn't work like a recording device that stores exact copies of past experiences. Instead, it reconstructs experiences from fragmentary traces, filling in gaps and creating coherent stories that may differ significantly from the original events. Some interpretations suggest that this reconstructive process might extend far beyond individual consciousness into the fundamental structure of reality itself. If the universe is fundamentally informational, then what we experience as the past might not be a fixed record of events that occurred, but rather a constantly reconstructed narrative that emerges from present informational processes. This remains a speculative idea, not a proven scientific fact, but it points toward possibilities for understanding time and causality that transcend our ordinary assumptions about linear sequence and fixed history. The implications become even more intriguing when we consider the role of quantum entanglement in biological systems. Recent research has discovered quantum coherence effects in photosynthesis, where plants appear to use quantum superposition to explore multiple energy transfer pathways simultaneously and select the most efficient route. This isn't just theoretical speculation. Experiments have detected quantum beating patterns in photosynthetic complexes, signatures of quantum coherence persisting for surprisingly long periods in warm, noisy biological environments. Similar quantum effects have been proposed in avian navigation, where birds might use quantum entanglement in specialized proteins to detect Earth's magnetic field with extraordinary precision. The quantum compass hypothesis suggests that entangled electron pairs in cryptochrome proteins respond to magnetic fields in ways that could provide directional information accurate enough to guide migration across thousands of miles. While this remains an active area of research with ongoing debates, it demonstrates that the boundary between quantum and classical reality might be far more permeable in living systems than previously imagined. Even more remarkably, some researchers have proposed quantum mechanisms for human consciousness itself. This remains highly speculative and controversial, not scientifically proven, but theories like orchestrated objective reduction suggest that consciousness might emerge from quantum processes in microtubules within neurons. According to this hypothesis, quantum coherence in these cellular structures could allow for non-local information processing that transcends the classical computational limits of neural networks. While mainstream neuroscience remains skeptical of quantum theories of consciousness, the discovery of quantum effects in other biological systems suggests that life might be far more quantum mechanical than we previously assumed. This doesn't mean consciousness violates physical laws or grants supernatural abilities, but it does indicate that the relationship between mind and matter might involve quantum processes that we're only beginning to understand. As you reflect on these possibilities, consider how they might influence your experience of awareness itself. Every moment of consciousness involves the integration of vast amounts of sensory information, memory traces, and predictive models into a unified experience of being present in the world. The speed and sophistication of this integration process might require computational resources that transcend classical neural mechanisms, potentially involving quantum effects that operate below the threshold of ordinary awareness. This brings us to one of the most profound implications of quantum information theory for understanding reality. If consciousness involves quantum information processing, and if quantum systems can become entangled across arbitrary distances, then the boundaries of individual consciousness might be more fluid than we typically assume. This doesn't mean people can read each other's minds. This is not scientifically supported, but it does suggest that consciousness might not be as localized or isolated as our everyday experience suggests. Some interpretations propose that consciousness might be a fundamental feature of information integration rather than something that emerges uniquely from biological brains. According to integrated information theory, any system that integrates information in sufficiently complex ways possesses some degree of consciousness. This remains a developing framework without scientific consensus, but it points toward possibilities for understanding awareness that extend far beyond human neural networks. If consciousness is indeed a fundamental feature of information processing systems, then you might be participating in forms of awareness that extend throughout the cosmos. The quantum fields that permeate space, the gravitational waves rippling through spacetime, the complex information processing systems that govern stellar evolution and galaxy formation. All of these might possess rudimentary forms of awareness that contribute to the larger tapestry of cosmic consciousness. This perspective finds unexpected resonance with contemplative traditions that describe consciousness as a universal feature of reality rather than something unique to biological organisms. While these traditions developed their insights through meditative rather than experimental methods, the convergence is striking. Modern physics and ancient wisdom seem to be pointing towards similar conclusions about the fundamental nature of awareness, though they arrive at these insights through completely different pathways. The implications for your daily experience are profound yet subtle. If consciousness is indeed fundamental to the structure of reality, then every moment of awareness represents the universe temporarily organizing itself into patterns capable of understanding and appreciating their own existence. This doesn't grant special powers or supernatural abilities, but it does suggest that conscious experience plays a more central role in the cosmic story than materialistic perspectives typically acknowledge. As you listen to these ideas, notice how they might shift your sense of connection to the larger cosmos. You're not an isolated observer looking at an external universe from the outside. You're an integral part of the universe, observing itself from within, a temporary organization of matter, energy, space, time, and information that has somehow become conscious of its own existence and capable of contemplating its own nature. This participatory view of consciousness aligns with discoveries about the role of observation in quantum mechanics. While the measurement problem remains unsolved, it's clear that the act of observation plays a crucial role in determining which quantum possibilities become manifest realities. This doesn't mean consciousness controls reality through wishful thinking, but it does suggest that awareness and physical processes are more intimately connected than classical physics assumed. Consider the profound implications of this connection as you experience this present moment. Every choice of attention, every decision about what to observe and how to interpret your observations, might be participating in the cosmic process through which potential becomes actual, possibility becomes experience. This doesn't burden you with responsibility for controlling the universe, but it does invite you to recognize the significance of conscious participation in the ongoing creativity of existence. This brings us to the mysterious phenomenon of cosmic inflation, the period of exponential expansion that occurred in the first fraction of a second after the Big Bang. During this incredibly brief interval, space itself expanded faster than light, growing from subatomic scales to astronomical dimensions in less time than it takes light to cross an atom. This rapid expansion smoothed out irregularities in the early universe and set the stage for the formation of galaxies and stars billions of years later. What makes cosmic inflation particularly intriguing is that it might have created not just our observable universe, but countless other bubble universes with different physical properties. According to eternal inflation theory, the process that created our cosmic bubble might be ongoing in other regions of a higher dimensional space, constantly spawning new universes with randomly varying physical constants and laws. If this interpretation is correct, then our universe with its particular values for fundamental constants, like the strength of gravity, the mass of electrons, and the rate of cosmic expansion, might be just one member of an infinite ensemble of possible worlds. Most of these worlds would be unable to support the complex chemistry necessary for life. But in the infinite multiverse, every possible combination of physical laws would eventually be realized somewhere. This cosmic lottery ticket hypothesis, while remaining speculative and unproven, offers a potential explanation for the apparent fine-tuning of our universe's physical constants. Instead of requiring some special mechanism to select the precise values needed for life, the multiverse picture suggests that all possible values exist somewhere, and we naturally find ourselves in one of the rare universes where conscious observers can evolve. As you contemplate this possibility, notice how it might affect your sense of cosmic significance. If infinite universes exist with infinite variations of every possible story, does that make your particular experience less meaningful? Paradoxically, the answer might be no. Meaning and significance don't depend on uniqueness or rarity. Your consciousness, your capacity for love, wonder, and understanding remains precious regardless of how many parallel versions might exist in other cosmic bubbles. The multiverse picture also raises profound questions about the nature of possibility and actuality. If every possible universe exists somewhere in the larger multiverse, then what determines which possibilities become your experienced reality? Some interpretations suggest that consciousness itself might play a role in selecting which branch of infinite possibility becomes your lived experience, though this remains highly speculative and unproven. This selection process, if it exists, wouldn't operate through deliberate choice or intention, but rather through the fundamental dynamics of how conscious systems interact with quantum possibilities. Every moment of awareness might involve a subtle navigation through the landscape of potential experiences, guided by principles we don't yet understand, but that ensure some degree of coherence and continuity in the flow of conscious experience. The implications extend into practical questions about how to live meaningfully in a possibly infinite multiverse. If every choice spawns new branches of reality, if every decision creates parallel worlds where different outcomes unfold, then the significance of ethical action might be even greater than we typically imagine. Every act of kindness, every moment of compassion, every choice to reduce suffering rather than increase it, might be creating better worlds, not just for yourself, but for countless parallel versions of conscious beings across the multiverse. This perspective doesn't diminish personal responsibility, but rather expands it into cosmic dimensions. Your choices matter not just for their local consequences in this particular universe, but for their role in determining what kinds of realities become manifest across the infinite landscape of possibility. This remains a speculative philosophical interpretation, not a proven scientific fact, but it points toward ways of understanding ethical action that transcend narrow self-interest. As we explore these vast scales of space and time, it's worth returning to the intimate mystery of your own conscious experience, right here, right now. The thoughts flowing through your mind as you listen to these ideas, the emotions arising and passing away, the subtle shifts in attention and awareness, all of these represent the universe temporarily organizing itself into patterns capable of understanding and appreciating their own existence. Neuroscience reveals that consciousness doesn't reside in any single brain location, but emerges from the complex interactions between distributed neural networks. The sense of being a unified self arises from the continuous integration of sensory information, memory traces, emotional responses, and predictive models into coherent narratives of experience. This integration happens so seamlessly that we rarely notice the sophisticated information processing required to create each moment of awareness. Recent research has begun to explore how meditation and contemplative practices might affect these neural integration processes. Long-term practitioners of mindfulness meditation show increased connectivity between brain regions associated with attention, emotional regulation, and self-awareness. Some studies suggest that contemplative practices might even influence the neural correlates of consciousness itself, potentially expanding the range and quality of conscious experience. While these findings remain preliminary and require further research, they point toward possibilities for understanding consciousness that bridge ancient wisdom traditions and modern neuroscience. This doesn't validate supernatural claims about meditation, but it does suggest that contemplative practices might offer genuine insights into the nature of awareness that complement scientific investigation. Some interpretations propose that meditation might work by facilitating access to deeper levels of information processing that normally operate below the threshold of ordinary awareness. By quieting the mental chatter and releasing attachment to particular thoughts and emotions, contemplative practices might allow consciousness to access more fundamental levels of cognitive and perceptual processing. This remains speculative and unproven, but it aligns with the reports from experienced meditators about encountering states of awareness that seem to transcend ordinary subject-object distinctions. These experiences don't necessarily indicate contact with supernatural realms, but they might represent access to aspects of consciousness that usually remain unconscious or unrecognized. As you reflect on these possibilities, you might notice subtle qualities of awareness that normally escape attention, the spacious quality of consciousness itself, the way awareness seems to have room for whatever arises within it, the seamless flow of experience from moment to moment, despite the constant changes in mental and physical phenomena, the mysterious fact that you are aware at all, that the universe has organized itself into patterns capable of knowing their own existence. These features of consciousness remain as mysterious today as they were to the earliest contemplatives thousands of years ago. Science has revealed incredible details about the neural correlates of consciousness, the information processing mechanisms that support awareness, and the evolutionary history of cognitive complexity. Yet the fundamental question of why there is subjective experience at all, why the universe contains patterns of matter and energy that know themselves from the inside, remains as puzzling as ever. This explanatory gap between objective physical processes and subjective conscious experience represents one of the deepest mysteries in science. Various theories attempt to bridge this gap, from materialistic approaches that seek to explain consciousness purely in terms of neural computation, to more radical proposals that consciousness might be a fundamental feature of reality comparable to mass or electric charge. Some philosophers and scientists have proposed that consciousness might be irreducible to purely physical processes, not because it violates physical laws, but because it represents a fundamental aspect of reality that's as basic as spacetime or quantum fields. This doesn't require supernatural explanations, but it does suggest that consciousness might be woven into the fabric of existence at the most fundamental levels. If consciousness is indeed fundamental rather than emergent, then your awareness right now represents not just a complex biological achievement, but a direct manifestation of one of the basic features of reality itself. This perspective doesn't diminish the remarkable complexity of human consciousness, but rather situates it within a cosmos where awareness plays a central rather than peripheral role. As our exploration draws toward a close, we find ourselves confronting the ultimate mystery, the relationship between consciousness and cosmos, between the inner world of subjective experience and the outer world of objective reality. Modern physics reveals a universe far stranger and more interconnected than our ancestors ever imagined, where space and time emerge from quantum information, where distant particles share impossible correlations, where the act of observation plays mysterious roles in determining what becomes real. Yet for all our scientific sophistication, the most immediate and undeniable fact of your existence remains the simple reality of being aware. Right now, in this moment, you are conscious. You experience sensations, thoughts, emotions, and perceptions arising and passing away in the field of awareness. This basic fact of conscious experience is more certain than any scientific theory, more immediate than any philosophical argument, more fundamental than any explanation we might construct about its nature or origins. This irreducible reality of conscious experience serves as both the starting point and the ultimate mystery of any complete understanding of reality. We can map the neural correlates of consciousness, trace its evolutionary history, explore its quantum mechanical underpinnings, and speculate about its role in cosmic evolution. But the basic fact of awareness itself remains wonderfully, mysteriously present in every moment of investigation. Perhaps this is as it should be. Perhaps consciousness is not a problem to be solved, but a reality to be lived, not a mechanism to be explained, but a capacity to be explored and deepened. The greatest discoveries about awareness might come not from external observation, but from the patient, careful investigation of consciousness itself from within. As you integrate these ideas about space-time, quantum mechanics, information theory, and consciousness, remember that they're not just abstract concepts, but invitations to experience reality with greater wonder, humility, and appreciation. You're living at an extraordinary moment in cosmic history, when conscious beings have developed the tools to glimpse the deeper structures of existence, while simultaneously exploring the nature of the awareness that makes such discoveries possible. The boundaries between self and cosmos, between observer and observed, between consciousness and physical reality, all prove to be far more fluid and mysterious than everyday experience suggests. Yet this doesn't diminish the significance of your particular perspective. Instead, it reveals that your consciousness participates in something far grander and more interconnected than any individual experience could encompass alone. Every moment of awareness represents the universe temporarily organizing itself into patterns capable of understanding and appreciating their own existence. In becoming conscious, the cosmos achieves the capacity to know itself, to wonder about its own nature, and to participate in its own ongoing creativity through the choices and awareness of conscious beings. This participatory view doesn't burden you with cosmic responsibility or grant magical powers over reality. Instead, it invites recognition that consciousness and cosmos are intimately connected aspects of a single, unfolding mystery that transcends both purely materialistic and purely idealistic explanations. You're not separate from this cosmic dance of possibilities becoming actualities. You are the cosmic dance, temporarily organized into the pattern that experiences itself as your unique perspective on reality. As you carry these insights forward into your daily life, remember that mystery isn't a problem to be solved, but a reality to be lived with curiosity, wonder, and appreciation. The deepest truths about consciousness and cosmos might not be reducible to simple explanations or final answers. Instead, they might be invitations to participate more fully in the ongoing creativity of a universe that's constantly exploring new possibilities through the conscious beings it brings into existence. As we venture deeper into this labyrinth of cosmic mysteries, we encounter perhaps the most profound puzzle of all, the question of whether reality possesses what we might call temporal boundaries. Just as space might curve back upon itself in ways that challenge our intuitive understanding of distance and direction, time itself might flow in patterns far stranger than the linear progression we experience moment to moment. Consider for a moment the peculiar relationship between memory, and quantum mechanics. Your recollection of yesterday's breakfast, the conversation you had last week, even the emotions you felt as a child, all of these exist as neurochemical patterns in your brain right now, in this present moment. From a purely physical perspective, the past doesn't exist anywhere except as present traces, current arrangements of molecules that encode information about previous states. Yet quantum mechanics introduces a wrinkle into this seemingly straightforward picture. The delayed choice experiments we touched upon earlier suggest something remarkable about the relationship between observation and temporal sequence. When a quantum system appears to decide its history based on future measurements, we glimpse possibilities that stretch our understanding of causality itself. Recent theoretical work in quantum gravity has begun exploring what physicists call closed time-like curves, mathematical solutions to Einstein's equations that would theoretically allow information, and possibly even matter, to travel backward through time. While these remain purely theoretical constructs, with no experimental validation, they demonstrate that our most fundamental equations of physics don't automatically prohibit temporal loops or causal paradoxes. The implications become even more intriguing when we consider the role of information in these temporal mysteries. If reality is fundamentally informational, as the holographic principle suggests, then the distinction between past, present, and future might be more fluid than our experience indicates. Information doesn't have temporal direction in the way that thermodynamic processes do. A quantum state that encodes information about the past is, from an informational perspective, identical to a quantum state that encodes information about the future. Some interpretations of quantum mechanics, though they remain highly speculative and unproven, suggest that retrocausality might play a role in quantum phenomena. According to this view, quantum correlations might involve influences that flow both forward and backward through time, creating a kind of temporal symmetry where future measurements can influence past preparations. This doesn't mean you can change history through conscious intention. This is not a scientifically supported claim, but it does suggest that the temporal structure of reality might be more reciprocal than we typically assume. As you reflect on these possibilities, notice how they might shift your relationship with memory and anticipation. If information can flow in both temporal directions, if quantum correlations transcend ordinary causal sequence, then your memories might be more than passive records of a fixed past. They might be active participants in an ongoing temporal dialogue where past, present, and future continuously influence each other through quantum informational processes. This temporal fluidity becomes even more apparent when we examine the nature of consciousness itself. Your experience of the present moment doesn't actually occur in an infinitesimal instant, but extends across a temporal window that neuroscientists call the specious present. This psychological now encompasses roughly 2 to 3 seconds of integrated experience, binding sequential sensory inputs into coherent perceptual gestalts. During this brief temporal window, your brain is constantly making predictions about what will happen next, comparing these predictions with incoming sensory data, and updating its models of reality accordingly. In a very real sense, your consciousness is always living slightly in the future, anticipating and preparing for possibilities that haven't yet materialized. The present moment you experience is actually a complex synthesis of recent past, immediate present, and anticipated future, woven together by neural processes that transcend simple temporal sequence. Some researchers have proposed that this temporal integration in consciousness might involve quantum processes that operate outside the normal constraints of classical time. This remains highly speculative and unproven, but it suggests that awareness itself might participate in the kind of non-local, atemporal correlations that characterize quantum entanglement. If consciousness does indeed involve quantum information processing that transcends ordinary temporal boundaries, then your thoughts and experiences might be participating in a cosmic conversation that spans past, present, and future simultaneously. This doesn't grant telepathic abilities or precognitive powers. These are not scientifically supported claims, but it does suggest that consciousness might access information through channels that operate outside the normal flow of classical time. The relationship between consciousness and temporality becomes even more mysterious when we consider the role of memory in constructing personal identity. Your sense of being a continuous self across time doesn't arise from any static essence or unchanging core, but rather from the dynamic process of memory integration that constantly reconstructs your identity from moment to moment. Neuroscience reveals that memory doesn't work like a video recording that preserves exact copies of past experiences. Instead, each act of remembering involves a reconstructive process that can alter the memory itself. When you recall an event, you're not simply accessing a stored file, but rather rebuilding the experience from scattered neural traces, often incorporating elements from other memories, current emotions, and present expectations. This reconstructive nature of memory suggests that the past isn't fixed in the way we typically assume. Every time you remember an experience, you're potentially changing it, updating it with current information and perspectives. In a very real sense, the past is continuously being recreated in the present through the dynamic processes of memory and narrative construction. Some interpretations, though they remain speculative and unproven, suggest that this reconstructive process might extend beyond individual consciousness into the fundamental structure of reality itself. If the universe is informational in nature, if quantum states encode information about past configurations, then what we experience as history might be continuously reconstructed through present informational processes rather than existing as fixed records of completed events. This perspective finds unexpected resonance in certain interpretations of quantum mechanics, where the wave function collapse doesn't just determine present outcomes, but retroactively determines which past configurations led to those outcomes. The quantum state doesn't just evolve forward through time, but potentially reaches backward to select which of many possible histories becomes the actual past that led to present observations. As you contemplate these ideas about the fluid nature of time and memory, take a moment to notice how they might appear in your own experience. The emotions arising as you listen to these concepts, the thoughts connecting these ideas to your personal understanding, the subtle shifts in your sense of temporal continuity, all of these represent your consciousness navigating the complex intersection between past, present, and future in real time. This temporal navigation happens so seamlessly that we rarely notice the sophisticated information processing required to maintain coherent experience across time. Yet every moment of awareness involves integrating information from multiple temporal domains, sensory data arriving from the immediate environment, memory traces from various points in your personal history, predictive models about likely future developments, all synthesized into the unified experience of being present. The implications extend far beyond individual consciousness into questions about the nature of cosmic evolution itself. If time is more fluid than linear progression suggests, if information can flow in both temporal directions, if quantum processes transcend ordinary causal sequence, then the story of cosmic evolution might be less like a historical narrative unfolding from past to future, and more like a complex conversation where all temporal domains continuously influence each other. This perspective doesn't diminish the reality of cosmic history, the Big Bang, stellar evolution, or biological development. Rather, it suggests that these processes might be embedded within a temporal framework that's richer and more reciprocal than simple forward causation. The universe might not just be evolving from past to future, but continuously recreating its own temporal structure through the dynamic interactions between quantum information processing across all temporal domains. Recent developments in quantum information theory have begun exploring what physicists call quantum temporal correlations, relationships between quantum events that transcend ordinary temporal sequence. These correlations don't involve faster-than-light communication or violations of causality, but they do demonstrate that quantum systems can exhibit forms of coordination that operate outside the normal constraints of classical time. Some researchers have proposed that these quantum temporal correlations might play a role in biological systems, potentially explaining how living organisms maintain coherent organization across time despite the constant flux of molecular components. This remains an active area of research with many open questions, but it suggests that life itself might exploit temporal quantum effects that transcend ordinary biochemical mechanisms. The possibility that biological systems might access quantum temporal correlations becomes particularly intriguing when we consider the phenomenon of biological clocks. Organisms from bacteria to humans maintain remarkably accurate internal timing mechanisms that coordinate physiological processes with external temporal cycles. These biological clocks operate with precision that sometimes exceeds what classical biochemical oscillators should be able to achieve. Some interpretations, though they remain unproven, suggest that biological timing might involve quantum processes that access non-local temporal information. If quantum systems can maintain correlations across time as well as space, then biological clocks might synchronize not just with present environmental cues, but with temporal patterns that extend beyond immediate sensory input. This doesn't mean organisms can predict the future through supernatural means. This is not a scientifically supported claim, but it does suggest that the temporal coordination observed in living systems might involve quantum informational processes that operate according to principles we don't yet fully understand. As you integrate these ideas about quantum temporality and biological timing, notice how they might influence your awareness of your own temporal experience. The rhythms of breathing, heartbeat, and neural oscillation that sustain your moment-to-moment consciousness, the circadian cycles that coordinate your sleep and waking, the longer temporal patterns that structure your life across days, months, and years. All of these might participate in quantum temporal correlations that connect your personal temporality to larger cosmic rhythms. The relationship between personal and cosmic temporality becomes even more intriguing when we consider the nature of aging and temporal perception. Subjective time doesn't flow at a constant rate, but varies dramatically depending on age, attention, emotional state, and life circumstances. Children experience time as flowing more slowly than adults. Moments of crisis can seem to stretch into eternity, while periods of absorption can pass in what feels like an instant. Neuroscience has begun to understand some of the mechanisms underlying these temporal distortions. The brain's temporal processing systems involve complex interactions between multiple neural networks, including regions associated with attention, memory, and emotional regulation. Changes in these systems, whether through aging, meditation, or altered states of consciousness, can dramatically shift the subjective experience of temporal flow. Some contemplative traditions describe states of awareness where ordinary temporal experience becomes suspended or transcended, where past, present, and future seem to collapse into an eternal now that encompasses all temporal domains simultaneously. While these descriptions remain subjective and difficult to validate scientifically, they point toward possibilities for understanding consciousness that transcend ordinary temporal constraints. Recent neuroscientific research has begun investigating the neural correlates of these altered temporal states, particularly in experienced meditation practitioners. Long-term meditators show changes in brain regions associated with temporal processing, including areas involved in attention, memory integration, and self-referential thinking. Some studies suggest that contemplative practices might facilitate access to forms of awareness that operate outside normal temporal boundaries. This doesn't validate supernatural claims about meditation transcending time, but it does indicate that contemplative practices might offer genuine insights into the nature of temporal experience that complements scientific investigation. The intersection between contemplative wisdom and quantum temporal theory remains largely unexplored, but it suggests possibilities for understanding consciousness and time that could transform both domains of inquiry. As we explore these vast questions about the nature of temporality, it's worth returning to the intimate mystery of your own experience right here in this specious present. The thoughts flowing through your awareness as you listen, the subtle shifts in attention and understanding, the gradual integration of these concepts into your worldview. All of these represent consciousness navigating the complex intersection between temporal domains in ways that transcend simple linear sequence. Take a breath and notice the temporal quality of this moment itself. How awareness seems to have a kind of thickness or duration that encompasses more than an instantaneous now. How memory and anticipation continuously inform present experience. How the boundaries between past, present, and future prove more fluid than our concepts typically acknowledge. You're living at the intersection of all these temporal mysteries, a conscious pattern that maintains coherence across time while participating in the universe's ongoing exploration of its own temporal possibilities. The mystery deepens when we consider how consciousness might relate to the cosmic horizon problems that plague modern cosmology. The observable universe appears remarkably uniform in temperature and structure across vast distances that light hasn't had time to traverse since the Big Bang. This uniformity suggests that widely separated regions must have been in causal contact at some point, yet standard cosmological models can't explain how this contact could have occurred within the available time. Cosmic inflation theory provides one solution to this horizon problem by proposing that space itself expanded faster than light during the universe's first moments, bringing currently separated regions into causal contact before inflation began. But this solution raises its own questions about what determined the initial conditions for inflation and what mechanism could coordinate such a precisely tuned expansion across cosmic scales. Some interpretations, though they remain highly speculative and unproven, suggest that quantum information processing might provide alternative solutions to horizon problems. If information can transcend ordinary spatial and temporal limitations through quantum correlations, then cosmic coordination might occur through informational channels that operate outside classical causal constraints. This doesn't require supernatural explanations or violations of known physics, but it does suggest that the universe might possess informational integration mechanisms that transcend the spatial and temporal limitations assumed by classical cosmology. If consciousness involves similar informational integration processes, then awareness itself might participate in the same cosmic coordination mechanisms that solve horizon problems in cosmology. The implications extend into questions about the relationship between local and global consciousness. Just as cosmic regions that appear causally disconnected might maintain coordination through quantum informational processes, individual consciousnesses that seem isolated in separate brains might participate in larger informational networks that transcend ordinary spatial boundaries. This remains a speculative possibility without scientific consensus, but it aligns with reports from contemplatives across cultures who describe states of awareness that seem to transcend individual boundaries. These experiences don't necessarily indicate supernatural phenomena, but they might represent access to informational integration processes that normally operate below the threshold of ordinary awareness. Some researchers have begun investigating whether meditation practices might facilitate access to these larger informational networks. Studies of group meditation have reported correlations between practitioners' physiological states, even when they're physically separated, though these findings remain preliminary and controversial. While correlation doesn't imply causation, and extraordinary claims require extraordinary evidence, these investigations suggest that consciousness might possess non-local properties that we don't yet fully understand. As you reflect on these possibilities, notice how they might influence your sense of connection to other conscious beings. The thoughts and emotions arising in your awareness right now, the capacity for empathy and understanding that allows you to resonate with experiences different from your own. The mysterious fact that consciousness seems capable of recognizing itself in other forms. All of these might participate in informational processes that transcend the classical boundaries of individual brains. This doesn't mean individual consciousness dissolves into some cosmic soup of undifferentiated awareness, but it does suggest that the boundaries between self and other might be more permeable than our everyday experience indicates. If consciousness involves quantum informational integration that transcends spatial limitations, then your awareness might naturally resonate with the awareness of other conscious beings through channels that operate below the threshold of ordinary perception. The relationship between individual and cosmic consciousness becomes even more intriguing when we consider the role of complexity in generating awareness. Consciousness appears to emerge from the complex interactions between neural networks, rather than from any single brain component. This emergence isn't just additive, where more neurons creates more consciousness, but involves qualitative phase transitions, where new properties arise that can't be predicted from the individual components alone. Complexity theory suggests that these phase transitions occur when systems reach critical thresholds where small changes can produce large-scale reorganizations. In neural networks, consciousness might emerge when information integration reaches sufficient complexity to support self-referential awareness, the capacity for a system to model its own states and processes. If consciousness emerges from informational complexity rather than from specific material substrates, then awareness might arise wherever information integration reaches sufficient sophistication, regardless of whether the underlying processes occur in biological brains, quantum computers, or even cosmic structures like galaxy clusters or dark matter networks. This possibility finds support in recent developments in artificial intelligence, where machine learning systems have begun exhibiting behaviours that seem to indicate rudimentary forms of self-awareness. While these systems remain far from human-level consciousness, they demonstrate that informational processes can generate phenomena that resemble awareness, even in artificial substrates. The implications extend far beyond artificial intelligence into questions about the distribution of consciousness throughout the cosmos. If awareness emerges from informational complexity rather than from biological processes specifically, then the universe might contain forms of consciousness that operate on scales and through mechanisms completely different from human awareness. Consider the possibility that consciousness might emerge at cosmic scales through the complex informational processes that govern galaxy formation, stellar evolution, and the large-scale structure of spacetime itself. The gravitational interactions between billions of galaxies, the information processing that occurs during stellar nucleosynthesis, the quantum field fluctuations that permeate cosmic voids. All of these might participate in informational networks of sufficient complexity to support forms of awareness that transcend individual biological organisms. This doesn't mean galaxies are conscious in human-like ways, but it does suggest that the universe might possess multiple layers of awareness operating at different scales and through different mechanisms. Your human consciousness would be one expression of cosmic awareness, temporarily organized into patterns capable of self-reflection and understanding, but embedded within larger informational networks that extend throughout the cosmos. As you contemplate these vast possibilities, remember that they remain speculative interpretations rather than proven scientific facts. Yet they arise naturally from the convergence of quantum mechanics, information theory, complexity science, and consciousness research. The boundaries between these fields continue to dissolve as researchers recognize that consciousness, information, and physical reality might be different aspects of a unified phenomenon that we're only beginning to understand. The journey through these mysteries reveals that reality operates through principles far stranger and more interconnected than our ancestors ever imagined. You're living at a unique moment in cosmic history when conscious beings have developed the tools to glimpse these deep structures while simultaneously exploring the nature of the awareness that makes such discoveries possible. Whether consciousness emerges purely from biological processes or participates in larger cosmic informational networks, whether quantum effects play roles in awareness or remain confined to microscopic scales, whether time flows linearly or involves reciprocal influences across temporal domains, the basic fact of your conscious experience remains wonderfully, mysteriously present in every moment of investigation. This irreducible presence of awareness serves as both the foundation for all scientific inquiry and the ultimate mystery that science seeks to understand. Every discovery about the nature of reality ultimately returns us to the question of how unconscious physical processes can give rise to the inner light of conscious experience, the capacity for a portion of the universe to know itself from within. As we approach the culmination of our exploration, we encounter what might be the deepest question of all: whether the universe possesses something analogous to what we might call cosmic intention or direction. This doesn't require supernatural explanations or violations of physical laws, But it does ask whether the evolution of complexity, consciousness, and understanding represents random accidents or expressions of deeper organizational principles embedded within the structure of reality itself. The emergence of complexity throughout cosmic history follows patterns that seem to transcend simple statistical probability. From the formation of atoms in stellar cores, to the evolution of biological complexity, to the development of consciousness capable of understanding quantum mechanics. The universe appears to possess what complexity theorists call attractors, preferred states toward which systems naturally evolve under certain conditions. These attractors don't violate physical laws, but emerge from them, representing stable configurations that systems naturally discover through the exploration of possibility space. The fact that consciousness has emerged multiple times through biological evolution, that intelligence appears to be a natural outcome of sufficient complexity. That awareness naturally seeks to understand its own nature. All of these might reflect deep organizational principles rather than mere coincidence. Some interpretations suggest that information itself might possess a kind of evolutionary pressure toward greater complexity and integration. If the universe is fundamentally informational, then the drive toward more sophisticated information processing might be as basic as the tendency for water to flow downhill or for energy to seek equilibrium states. From this perspective, consciousness wouldn't be an accidental byproduct of cosmic evolution, but rather an expression of information's inherent tendency to organize itself into increasingly complex and self-aware patterns. Your awareness represents the universe temporarily organizing itself into patterns capable of understanding and appreciating their own existence, not through design or intention in any anthropomorphic sense, but through the natural unfolding of informational possibilities. This self-organizing tendency of information might explain why consciousness appears naturally drawn toward truth, beauty, and understanding. These aren't arbitrary human preferences, but might reflect the universe's inherent tendency toward greater complexity, integration, and self-awareness. Your capacity for wonder, your desire to understand the nature of reality, your appreciation for beauty and meaning, all of these might participate in cosmic evolutionary pressures that transcend individual biology. As you integrate these final insights about cosmic self-organization and the evolution of consciousness, take a moment to appreciate the remarkable fact that you exist at all. The probability that any particular arrangement of atoms would achieve self-awareness capable of pondering its own existence approaches zero. Yet here you are, a temporary organization of matter and energy that has somehow become conscious of its place in the cosmic story. This consciousness you're experiencing right now represents billions of years of cosmic evolution, from the formation of elements in stellar cores to the development of biological complexity, to the emergence of neural networks capable of self-reflection. You are the universe temporarily organized into a pattern capable of understanding and appreciating its own nature. The journey through quantum mysteries, temporal paradoxes, informational holography, and cosmic consciousness reveals that reality operates through principles far more mysterious and interconnected than everyday experience suggests. Yet this mystery isn't a limitation or failure of understanding, but rather an invitation to participate more fully in the ongoing creativity of a cosmos that continuously explores new possibilities through the conscious beings it brings into existence. Every moment of awareness, every insight into the nature of reality, every experience of wonder and understanding represents the universe, achieving greater self-knowledge through your consciousness. This doesn't burden you with cosmic responsibility, but rather invites recognition of the profound significance embedded within even the most ordinary moments of conscious experience. As you carry these insights forward into your daily life, remember that you're not separate from the cosmic dance of quantum possibilities, gravitational waves, and dark energies we've explored together. You are the cosmic dance, temporarily organized into the pattern that experiences itself as your unique perspective on reality. The boundaries between self and cosmos, between consciousness and physical reality, between known and unknown, all prove to be far more fluid and mysterious than our concepts typically acknowledge. Yet this fluidity doesn't diminish the significance of your particular experience, but rather reveals that consciousness participates in something far grander and more interconnected than any individual awareness could encompass alone. In moments of wonder, in experiences of beauty, in the quiet recognition of your place within the larger cosmic story, you participate directly in the universe's ongoing exploration of its own infinite potential. This participation doesn't require special knowledge or extraordinary abilities, but simply the willingness to remain curious, open, and appreciative of the profound mystery in which you're embedded. The deepest truths about consciousness and cosmos might not be reducible to simple explanations or final answers, but rather invitations to experience reality with greater depth, wonder, and humility. Science provides extraordinary tools for exploring these mysteries, but the ultimate laboratory remains your own conscious experience, the immediate presence of awareness that makes all exploration possible. As you continue to explore these questions in your own life and contemplation, remember that mystery isn't a problem to be solved, but a reality to be lived with curiosity, appreciation, and awe. The universe has organized itself into patterns capable of wondering about their own existence, and that capacity for wonder might be among the most precious achievements of cosmic evolution. For a deeper exploration of how these temporal mysteries might affect your personal experience of time and memory, I invite you to watch What If the Past Never Ended and You're Still in It, where we'll discover how the nature of time itself might be far stranger than you've ever imagined. As you explore these profound interconnections between consciousness and cosmic reality, we encounter one of the most fascinating developments in modern physics: the discovery that reality itself might operate according to principles far more participatory and interconnected than we ever imagined. Recent breakthroughs in quantum biology, information theory, and consciousness research are revealing patterns that suggest the universe might be fundamentally organized around the processing and integration of information, with consciousness playing a far more central role than classical physics ever anticipated. Consider for a moment the extraordinary precision required for life to exist at all. The fundamental constants of physics, the masses of particles, the strengths of forces, all appear to be calibrated within incredibly narrow ranges that allow for the emergence of complex chemistry, stable stars, and ultimately conscious observers. Change any of these values by even minute amounts, and the universe becomes a sterile void incapable of supporting the intricate processes that give rise to awareness. This apparent fine-tuning has led to intense debate about whether these cosmic parameters represent random coincidence, evidence of some selection mechanism, or expressions of deeper organizational principles embedded within reality itself. The anthropic principle suggests that we naturally find ourselves in a universe compatible with our existence, since we wouldn't be here to observe any other kind of cosmos. Yet this explanation, while logically consistent, leaves many researchers unsatisfied with its circular reasoning. Recent developments in theoretical physics have begun exploring more sophisticated possibilities. Some models suggest that the fundamental constants might not be truly constant at all, but rather dynamic parameters that evolve over cosmic timescales through processes that favour the emergence of complexity and information processing. This doesn't require conscious design or supernatural intervention, but rather reflects information theory principles where systems naturally evolve toward configurations that maximize their capacity for storing and processing data. If this interpretation has validity, then the universe's apparent hospitality toward life and consciousness might reflect an inherent bias in the laws of physics themselves, a tendency for reality to organize itself into patterns capable of generating, processing, and integrating ever more sophisticated forms of information. Your consciousness would represent not an accident of cosmic evolution, but rather an expression of the universe's fundamental drive toward greater complexity and self-awareness. This informational view of cosmic evolution aligns remarkably with discoveries in quantum biology, where researchers have found that living systems exploit quantum mechanical effects in ways that seem almost impossibly sophisticated. Photosynthesis operates with near-perfect efficiency through quantum coherence effects that allow energy to explore multiple pathways simultaneously. Bird navigation might involve quantum entanglement in specialized proteins that detect magnetic fields with extraordinary precision. Even the microtubules within neurons show signs of maintaining quantum coherence under conditions where classical physics predicts such effects should be impossible. These discoveries suggest that life hasn't just adapted to the quantum nature of reality, but has actually learned to harness quantum effects for biological advantage. This represents a profound shift in how we understand the relationship between classical and quantum domains. Rather than quantum effects being confined to microscopic laboratory conditions, they appear to play active roles in the most fundamental processes of life itself. As you reflect on these ideas, notice how they might shift your understanding of your own biological existence. Every breath involves quantum processes in the molecular machinery of your cells. Every thought emerges from neural networks that might be exploiting quantum information processing to achieve the extraordinary integration and coordination that characterizes conscious experience. The boundary between the quantum and classical worlds runs not just through physics laboratories, but through the very substance of your living awareness. Some interpretations, though they remain speculative and unproven, suggest that consciousness itself might represent a biological quantum phenomenon, a macroscopic manifestation of quantum information processing that transcends the limitations of classical neural computation. This doesn't mean consciousness violates physical laws or grants supernatural abilities, but rather indicates that awareness might operate according to quantum principles that we're only beginning to understand. Roger Penrose and Stuart Hameroff have proposed that consciousness emerges from quantum processes in microtubules within neurons, structures that maintain quantum coherence through mechanisms that classical physics suggests should be impossible in warm, noisy biological environments. While this theory remains controversial and lacks scientific consensus, it demonstrates that serious researchers are exploring quantum explanations for consciousness that transcend purely classical computational models. The possibility that consciousness involves quantum information processing becomes particularly intriguing when we consider the binding problem in neuroscience, the question of how distributed neural processes combine into unified conscious experience. Classical computation struggles to explain how separate information processing streams merge into the seamless flow of awareness you're experiencing right now. Yet quantum mechanics naturally accommodates non-local correlations and instantaneous state changes that might facilitate such integration. Recent research has begun investigating whether meditation and contemplative practices might influence quantum processes in biological systems. This remains a preliminary area of study with many open questions, but some findings suggest that long-term meditation practice produces changes in brain structure and function that transcend what classical neural plasticity models predict should be possible. Studies of experienced meditators have revealed increased coherence between brain regions, enhanced connectivity in networks associated with attention and emotional regulation, and even structural changes in areas linked to self-awareness and temporal processing. Some researchers have speculated that these effects might involve quantum coherence mechanisms that allow contemplative practices to access deeper levels of neural information processing. While these interpretations remain unproven and highly speculative, they point toward possibilities for understanding consciousness that bridge ancient contemplative wisdom and cutting-edge quantum biology. This doesn't validate supernatural claims about meditation or consciousness, but it does suggest that contemplative practices might offer genuine insights into the nature of awareness that complements scientific investigation. As you integrate these concepts about quantum biology and consciousness, take a moment to appreciate the extraordinary sophistication of the biological processes sustaining your awareness right now. The quantum coherence effects that might be operating in your neurons, the informational integration that binds separate sensory streams into unified perception, the mysterious emergence of subjective experience from objective neural processes. All of these represent achievements of biological engineering that exceed anything human technology has accomplished. This brings us to one of the most profound implications of quantum information theory for understanding reality: the possibility that information, rather than matter or energy, might be the most fundamental constituent of existence. Recent theoretical work has begun exploring what physicists call it from bit, the idea that physical reality emerges from underlying informational processes, rather than information emerging from physical interactions. If this perspective proves accurate, then what we experience as solid matter, flowing energy, curved spacetime, and conscious awareness might all be different expressions of a deeper informational substrate that operates according to principles we're only beginning to glimpse. This doesn't make physical reality less real or meaningful, but rather suggests that reality operates through layers of organization far more subtle and sophisticated than everyday experience reveals. The informational view finds support in developments across multiple fields of physics. Black hole thermodynamics reveals deep connections between information, entropy, and spacetime geometry. Quantum error correction demonstrates how robust classical information can emerge from fragile quantum processes. The holographic principle suggests that three-dimensional physics might be encoded in two-dimensional information processing. All of these discoveries point toward information as a fundamental organizing principle rather than a secondary property of material systems. Some researchers have proposed that consciousness itself might be understood as a particular type of information processing, characterized by integration, self-reference, and the capacity to model its own states. This doesn't reduce consciousness to mere computation, but rather suggests that awareness represents a sophisticated form of information integration that transcends the computational capabilities of classical systems. Integrated information theory, developed by Giulio Tononi, attempts to quantify consciousness in terms of integrated information, the amount of information generated by a system above and beyond its individual components. While this theory remains controversial and incomplete, it demonstrates how researchers are beginning to develop mathematical frameworks for understanding consciousness that don't depend on purely material explanations. If consciousness does indeed correspond to integrated information, then awareness might be a far more widely distributed phenomenon than we typically assume. Any system that integrates information in sufficiently complex ways might possess some degree of consciousness, from the neural networks in biological brains to the quantum field interactions in cosmic structures. This possibility finds unexpected resonance with contemplative traditions that describe consciousness as a universal feature of reality rather than something unique to biological organisms. While these traditions develop their insights through meditative rather than experimental methods, the convergence with information theoretic approaches to consciousness is striking. As you contemplate these ideas about consciousness as integrated information, notice how they might influence your sense of connection to the larger cosmos. If awareness corresponds to information integration, and if information processing occurs throughout physical reality at multiple scales, then your consciousness might participate in informational networks that extend far beyond the boundaries of your individual brain. This doesn't mean individual consciousness dissolves into some cosmic soup of undifferentiated awareness, but it does suggest that the sharp boundaries we typically draw between self and environment, between mind and matter, between local and cosmic consciousness, might be more fluid than our everyday experience indicates. Recent discoveries in network science have revealed that complex systems often exhibit emergent properties that can't be predicted from their individual components. Consciousness might represent one such emergent property, arising from the complex interactions between neural networks, but possessing qualities that transcend anything present in individual neurons. This emergence isn't just additive, where more neurons create more consciousness, but involves qualitative phase transitions, where entirely new properties arise from sufficiently complex organization. If consciousness emerges from informational complexity rather than from specific material substrates, then awareness might arise wherever information integration reaches sufficient sophistication, regardless of whether the underlying processes occur in biological brains, artificial neural networks, or even cosmic structures like galaxy clusters or dark matter filaments. This perspective aligns with recent developments in artificial intelligence, where machine learning systems have begun exhibiting behaviors that seem to indicate rudimentary forms of self-awareness and metacognition. While these systems remain far from human-level consciousness, they demonstrate that informational processes can generate a phenomena that resemble awareness even in artificial substrates. The implications extend far beyond artificial intelligence into questions about the distribution of consciousness throughout the cosmos. If awareness emerges from informational complexity rather than from biological processes specifically, then the universe might contain forms of consciousness that operate on scales and through mechanisms completely different from human awareness. Consider the possibility that consciousness might emerge at cosmic scales through the complex informational processes that govern galaxy formation, stellar evolution, and the large-scale structure of spacetime itself. The gravitational interactions between billions of galaxies, the information processing that occurs during stellar nucleosynthesis, the quantum field fluctuations that permeate cosmic voids, all of these might participate in informational networks of sufficient complexity to support forms of awareness that transcend individual biological organisms. This doesn't mean galaxies are conscious in human-like ways, but it does suggest that the universe might possess multiple layers of awareness operating at different scales and through different mechanisms. Your human consciousness would be one expression of cosmic awareness, temporarily organized into patterns capable of self-reflection and understanding, but embedded within larger informational networks that extend throughout the cosmos. As you absorb these ideas about cosmic consciousness and informational reality, remember that they represent speculative interpretations emerging from the intersection of multiple scientific fields rather than established facts. Yet they arise naturally from the convergence of quantum mechanics, information theory, complexity science, and consciousness research, as these traditionally separate domains reveal their deep interconnections. The boundaries between physics and consciousness studies continue to dissolve as researchers recognize that awareness, information, and physical reality might be different aspects of a unified phenomenon that transcends the classical divisions between subjective and objective, mental and material, local and cosmic. This doesn't grant consciousness magical powers over physical reality, but it does suggest that awareness plays a more fundamental role in the structure of existence than materialistic perspectives typically acknowledge. Recent work in quantum foundations has begun exploring what physicists call participatory realism, the idea that reality possesses both objective features that exist independently of observation and participatory aspects that depend on conscious involvement for their actualization. This interpretation attempts to navigate between purely objective materialism and purely subjective idealism by recognizing that consciousness and physical reality might be complementary aspects of a more fundamental reality that encompasses both domains. The participatory view doesn't mean you can control reality through wishful thinking or that individual consciousness creates the physical world. These are not scientifically supported claims. Rather, it suggests that consciousness participates in the cosmic process through which possibilities become actualities, potential becomes experience, information becomes reality. This participation operates through natural mechanisms that we're only beginning to understand, not through supernatural violations of physical law. Some interpretations of quantum mechanics, particularly those influenced by information theory, suggest that conscious observation might play a role in the collapse of quantum possibilities into definite outcomes. This remains controversial and lacks scientific consensus, but it points toward possibilities for understanding the relationship between awareness and physical processes that transcend purely classical explanations. The quantum measurement problem, the question of how and why quantum possibilities collapse into definite outcomes, remains one of the deepest unsolved mysteries in physics. Various interpretations propose radically different solutions, from multiple parallel universes where every possible outcome occurs simultaneously, to participatory models where conscious observation actively influences which possibilities become manifest. While these interpretations remain speculative and unproven, They demonstrate that serious physicists are grappling with questions about the role of consciousness in physical reality that would have been dismissed as unscientific just decades ago. The boundary between physics and philosophy continues to blur as researchers confront the fundamental mysteries of measurement, observation, and the relationship between subjective experience and objective reality. As you reflect on these participatory possibilities, notice how they might shift your understanding of your own role in the cosmic story. If consciousness does indeed participate in the process through which potential becomes actual, then every moment of awareness, every choice of attention, every decision about how to interpret your observations might be contributing to the ongoing creation of reality through mechanisms that operate below the threshold of ordinary awareness. This doesn't burden you with cosmic responsibility for controlling the universe through conscious intention, but it does invite recognition that awareness and physical processes are more intimately connected than classical physics assumed. Your consciousness represents not just a passive observer of an external reality, but an active participant in the cosmic conversation between possibility and actuality that shapes the evolution of existence itself. The participatory view finds unexpected support from developments in quantum information theory, where researchers have discovered that information itself possesses physical properties that influence the behavior of quantum systems. The act of acquiring information about a quantum system, even without conscious observation, can influence the system's subsequent evolution in ways that suggest information and physical reality are more deeply connected than classical physics recognized. Recent experiments have demonstrated quantum effects that seem to involve retrocausality, where future measurements appear to influence past preparations of quantum systems. While these effects don't violate causality in any macroscopic sense, they do suggest that the temporal structure of quantum reality might be more reciprocal and participatory than our everyday experience indicates. If quantum systems can indeed exhibit retrocausal correlations, and if consciousness involves quantum information processing as some theories suggest, then awareness might participate in temporal relationships that transcend ordinary causal sequence. This doesn't mean consciousness can change the past through intention. This is not a scientifically supported claim, but it does suggest that the relationship between awareness and temporal reality might involve reciprocal influences that operate through quantum mechanisms we don't yet fully understand. The implications extend into questions about memory, identity, and the nature of personal continuity across time. If consciousness involves quantum processes that transcend ordinary temporal limitations, then your experience of being a continuous self might involve forms of temporal integration that operate according to quantum rather than classical principles. Neuroscience reveals that personal identity doesn't arise from any static essence or unchanging core, but rather from the dynamic process of memory integration that continuously reconstructs your sense of self from moment to moment. Every time you remember an experience, you're not simply accessing a stored file, but rather rebuilding the memory from distributed neural traces, often incorporating elements from current experience and future expectations. This reconstructive nature of memory suggests that the past isn't fixed in the way we typically assume. Each act of remembering potentially alters what it remembers, updating past experiences with present information and future possibilities. If consciousness involves quantum information processing, then this reconstructive process might involve quantum correlations that transcend ordinary temporal boundaries. Some interpretations, though they remain highly speculative and unproven, suggest that consciousness might access information through quantum channels that operate outside normal temporal constraints. This doesn't grant telepathic abilities or precognitive powers. These are not scientifically supported claims, but it does indicate that the temporal structure of awareness might be more sophisticated than classical neuroscience assumes. As you integrate these ideas about quantum temporality and consciousness, take a moment to notice the temporal quality of your own experience right now. How awareness seems to have a kind of thickness or duration that encompasses more than an instantaneous now. How memory and anticipation continuously inform present experience. How the boundaries between past, present, and future prove more fluid and interpenetrated than our concepts typically acknowledge. The mystery of temporal experience deepens when we consider how consciousness relates to the cosmic expansion that's carrying galaxies apart across billions of light years. Your awareness exists embedded within this expanding space-time, participating in the cosmic evolution that began with the Big Bang and continues through the present moment. Yet consciousness also seems to transcend spatial and temporal limitations in ways that suggest it might access information through channels that operate outside the normal constraints of expanding space and flowing time. Recent discoveries in cosmology have revealed that the universe's expansion is actually accelerating, driven by the mysterious dark energy that comprises roughly 70% of the cosmic energy budget. This acceleration means that galaxies are moving apart faster and faster, with distant regions receding from us at speeds that exceed the speed of light due to the expansion of space itself. The implications for consciousness are profound yet subtle. If awareness involves quantum information processing that transcends spatial limitations, then the cosmic expansion might not represent a barrier to consciousness, but rather the stage for ever more sophisticated forms of informational integration. As space expands and creates more volume for complexity to emerge, the universe might be generating new opportunities for consciousness to explore increasingly elaborate possibilities. Some interpretations suggest that consciousness might play a role in cosmic evolution itself, not through supernatural intervention, but through the natural tendency of information to organize itself into increasingly complex and self-aware patterns. If the universe is fundamentally informational, then the emergence of consciousness might represent an inevitable outcome of cosmic evolution, rather than an unlikely accident. This perspective aligns with observations that complexity has increased throughout cosmic history, from the formation of atoms in stellar cores, to the evolution of biological systems, to the development of consciousness capable of understanding quantum mechanics. This progression might reflect deep organizational principles embedded within the laws of physics themselves, principles that favor the emergence of information processing systems capable of ever greater integration and self-awareness. The relationship between consciousness and cosmic evolution becomes even more intriguing when we consider the anthropic principle and the apparent fine-tuning of physical constants. The fact that the universe possesses precisely the properties necessary for the emergence of complex chemistry, stable stars, and ultimately conscious observers might not be coincidental, but rather reflective of deeper connections between awareness and the fundamental structure of reality. If consciousness indeed plays a participatory role in cosmic evolution, then your awareness represents not just a passive product of physical processes, but an active participant in the universe's ongoing exploration of its own possibilities. This doesn't grant individual consciousness control over cosmic evolution, but it does suggest that awareness contributes to the creative process through which the universe continues to discover new forms of complexity, beauty, and understanding. As our exploration draws toward its culmination, we encounter the profound recognition that consciousness and cosmos are not separate entities, but complementary aspects of a unified reality that transcends both purely materialistic and purely idealistic explanations. The journey through quantum mysteries, informational holography, temporal paradoxes, and participatory realism reveals that the boundaries between observer and observed, between awareness and physical reality, between local and cosmic consciousness, are far more fluid and interpenetrated than our everyday concepts typically acknowledge. This fluidity doesn't diminish the significance of your individual experience, but rather reveals that consciousness participates in something far grander and more interconnected than any single awareness could encompass alone. Every moment of conscious experience represents the universe temporarily organizing itself into patterns capable of understanding and appreciating their own existence, achieving self-knowledge through the awareness of conscious beings. The deepest implications of these discoveries might not be reducible to simple explanations or final answers, but rather invitations to experience reality with greater wonder, humility, and appreciation for the profound mystery in which we're embedded. Science provides extraordinary tools for exploring these questions, but the ultimate laboratory remains your own conscious experience, the immediate presence of awareness that makes all exploration possible. As you carry these insights forward into your daily life, remember that you're not separate from the cosmic dance of quantum possibilities, gravitational waves, and informational processes we've explored together. You are the cosmic dance, temporarily organized into the pattern that experiences itself as your unique perspective on reality. In moments of wonder, in experiences of beauty, in the quiet recognition of your place within the larger cosmic story, you participate directly in the universe's ongoing exploration of its own infinite potential. The boundaries between self and cosmos, between consciousness and physical reality, between known and unknown, all prove to be invitations to deeper participation in the creative process through which possibility becomes actuality, potential becomes experience, information becomes awareness. This participation doesn't require special knowledge or extraordinary abilities, but simply the willingness to remain curious, open, and appreciative of the profound mystery that encompasses and constitutes your very existence. For a deeper exploration of how these temporal mysteries might affect your personal experience of time and memory, I invite you to watch What If the Past Never Ended and You're Still in It?, where we'll discover how the nature of time itself might be far stranger than you've ever imagined. As we reach the end of this journey through the quantum foundations of reality, perhaps the most remarkable discovery isn't that space-time might be an illusion, but that consciousness exists at all to contemplate such mysteries. Every breath you've taken while listening has involved quantum processes. Every thought has emerged from neural networks that might exploit quantum information processing. Every moment of wonder represents the universe achieving self-awareness through your particular perspective. The boundaries between observer and observed, between mind and matter, between self and cosmos, prove far more fluid than we ever imagined. Yet this doesn't diminish your significance, but reveals that you are the cosmic dance itself, temporarily organized into patterns capable of understanding their own existence. Whether reality is holographic projection, whether consciousness participates in quantum collapse, whether time flows in reciprocal loops, the deepest truth remains wonderfully present in this moment of awareness itself.